We're going to be learning about pyramids today, and specifically how to find their volume. Now, if we were in the classroom, I'd have you guys make some cool pyramids by cutting out their nets and taping them together. But I guess I get to do that now. So I don't know if I'll cut this part or if I'll maybe like fast forward it really cool. All right, so we magically now have some pyramids. Pyramids have a polygon base, so, shape with straight edges. And then each of those vertices, gets connected to a single point at the top called the apex. So in this one, we have a hexagon, and they all come up to a point. So we get this three-dimensional shape. So this is a hexagon-based pyramid, and you can name the pyramids by their base shapes. A very common base shape for a pyramid is a square. So a square-based pyramid, I think, I could be wrong, but I'm pretty sure that's like the pyramids in Egypt are usually square-based pyramids. So we've got square connected all up to a single point, and you get triangles on all the sides. Notice that no matter what shape you use on the bottom, you're going to get triangles on the sides. Because if you connect the two edges to a point, you're going to get a triangle. Now, pyramids are often centered at the top. So the center point everything connects to is going to be at the exact center, like this is at the exact center of the hexagon base. When you look at it lined up like that, this is at the exact center of the square base when you look at it lined up like that. But not every pyramid has to be that way. For example, this pyramid doesn't look like that. So you still have your square base, and then, but when it connects up, it's centered actually, in this case, directly above one of the corners of the square base. It's kind of an interesting shape. Now, I want us to actually figure out the volume of pyramids today. And to get the volume of a pyramid, we're going to have to be a little bit tricky because the careful mathematical way to do this involves calculus. But I think I can convince you guys using our little pieces of paper here. So one thing I want you to think about is that most of the volume formulas we've thought about so far, think about taking a shape, finding the area of its base and multiplying it by its height. But that would only work if it was the same all the way through. This shrinks as it goes through. So this should be some amount smaller than doing the area of the base than the height. And what I want us to think about is a trick. Can we figure out how many of these it would take to create a shape that would be the same all the way up to the top? Now, to do that, I'm going to need to do a little trick. Which is, I want us to compare these two pyramids. They have, one is pyramid B and one is pyramid C. I guess I have that B upside down, but you can figure it out. Whatever. Now the C is upside down. Hey, I did it. Anyway, the point is the square bases are exactly the same. I don't know how well you can see that, but when I line these up with each other, they are exactly the same size of base. So the base area is exactly the same. They are also exactly the same height. And once again, I don't know how well I can demonstrate that for you, but notice that if they sit flat next to each other, I'm not laying these perfectly flat because my hand's not perfectly flat, but these come to exactly the same height from the base. But you'll notice that one is centered above the middle of the shape. There we go. And this one is the one that was centered above one corner of the shape. See? So a little bit different. What I want you to think about, though, is whether or not these would have the same volume. Would they fill the same amount of space? Well, if we thought about slicing this into thin layers and then just pushing them over, kind of like you had a stack of like a deck of cards and you just like slide them over. It takes up the same amount of space even though you get an angled edge. And I might be able to put up a graphic on the side here of what I'm talking about. The point is that because these have the same base area and the same height, you could cut this up into a bunch of little square cross sections. You could cut this one up into a bunch of little square cross sections, and those are all going to be the same size of pieces. And then we can slide this one all over to the edge here, and they cover up the same amount of space, even though they're stacked and arranged in a slightly different way. So now, because I've rearranged this volume a little bit by just cutting it up and sliding it over, I'm now going to say, what if I had another identical copy of it? And then what if I had a third identical copy of it? So these are three identical, so we could say congruent pyramids, and all of them have the same volume as each other. Now we're going to play a little stacking game. So I'm going to stack these two together like this. Actually, I got to figure out, there's a certain way these go together nicely. Okay, so that stacks together like that. And then I'm going to bring in one more of them. So this is three congruent pyramids. And I'll try to see how well we can get this on camera. Better. So you guys can probably see that this is a cube, or at least if I had put it together and taped all these things perfectly, this would be a really nice cube. So this is a cube, and this is a shape that we could find the volume of. So we could find the volume by doing the area of the base and times the height. And that would get us the volume. And so the volume is going to be simple to calculate, except that, remember, we could now divide this by 3 and get one of these pyramid shapes. So what we just figured out is that the volume of this pyramid is going to be its base area, which, remember, its base is the same as the base of the cube, and we can then multiply it by its height. So the volume formula for a pyramid is the base area times its height and then divided by 3. Or the other way you can think about it is 1/3 of the base area times the height. And then when we're talking about height, it's important to remember we're not talking about a slanted edge length. We're talking about when we have arranged this into this cube, the base area is at a 90-degree angle to the base. That height is at a 90-degree angle to the base. So in a pyramid where the point is not, when the point's like in the center like this, the trick to that is that you'd be actually measuring, like if you drop something straight down from the top to hit the bottom, it would be like a line straight down the center of this 3D object. It's not one of these slanted lengths. It's not a line out here. So the volume formula for pyramids is 1/3 of the base area times the height. Now this would be more complicated to demonstrate if the base was not a square, if it was something like this hexagon, but I promise that if we took this hexagon, made 2 more copies of it, so we had 3 of them, and we chopped them up just the right way, we could stack this to be the base area times the height and be like the same all the way through. So this does work no matter what the base area is. Now, if you also compare this to cones, which we've talked about before, they are also the base area times the height divided by 3. They're 1/3 of a cylinder, and think about it, a cone is basically a circle-based pyramid, if you just think about how the shapes look, right? Okay, so that's the formula. Now, what I want you guys to do then is find the volume of some pyramids, and I'll give you the problem. Well, actually, maybe we'll find the volume of this pyramid, and I'll give you some measurements for it. So we want to find the volume of this shape, and the measurement is, it has a square base, and I've measured along here, and it's 6 centimeters. I rounded slightly, but we'll call this a 6 centimeter base. So all of these square edges are 6 centimeters each. And then I measured straight up the middle of this, and I got 6.5. Now remember, that is not the height of the shape. The height would be straight up and down, which is going to be different than this line down here. It's also different than this slant height here. So you'll have to figure out, how would you use these measurements to get the height straight down the middle? So let's see if we can figure that out. Think it through, and I'll give you guys an answer in a little bit.